Boom. And just like that, 6 minutes past the hour. Today is Saturday, August 8th, 2026. This early morning or late afternoon, whatever in the world you are, thank you for joining. We start session 370 of Tesos and Wi-Fi. This session, part of the free, 100% free, 98% in English, Wireless LAN Professionals Wi-Fi Design class. You know, we started this a while ago, and here we go. One session at a time, man. Today we're learning about Hamina. Number one design tool when it comes to Wi-Fi design. Without a doubt, by a long shot. So we're almost, well, we're not coming to the end of the design with Hamina portion. We will be taking on CIDOs after this, whenever session it is, because we start with a plan in mind, and then we start talking about other important things, and then we just cover what we need to cover. And, you know, if something comes up and we need a learning all together, then, you know, we get the experts in here, and we've learned a lot from Jerry this week, huh, guys? That's been pretty cool. And about AFC and learning about, you know, a point-to-point simulation stuff and all the cabling, all of the options that we use in design. We started with the edit. Anybody here that does not have a license? I guess everybody here should be covered, huh? Yeah, everybody should have a license and the floor plans. So we should be good. We won't have time like to stop, dude, and wait for you to do it. But I told you, do a homework, just work on the concepts we learn. And then when we come back to a session, just ask away. You know, whatever questions we have, we'll address them. So we've looked at all the options right now. The edit is what we use to select stuff and move things around and select attenuation areas and access points and stuff. We added also nodes to the floor plan and nodes to an access point. If we have an access point like this one I see here, that guy has a little node thing in it, because if you click on an access point, inside the access point, we added a node. Now, how do we add that node to that AP? I don't even remember. Let's see. We come, where are my glasses? Look at my glasses. We added right here the node, but where was the button? Like when you don't have a node on an access point. Let's see, come to this access point. Oh, right there. That little like dialogue icon, that's where you add a node. So this doesn't have a node. You can add a node from there. You can also change the color. See this little button right there, it says blue. If I click on it, and let's say I want to make this AP red. Well, orange, I guess, because I don't see red in there. Let's make this reddish orangey color. Then you can have, let me show you why that's really cool. And we'll use it later too. But then let's say that one, I'm going to make a different color. I'm going to make this guy purple. Then I can, and I'll show you this at big scale later, have a specific model of AP or a specific height of an access point be a color. So if I want to change like something on only the purple APs, then I select the purple APs. If I want to change only the blue APs, maybe I'm talking about all of the APs are going to be in the ceiling, or I'm going to talk about all the APs that are going to be down low on the wall, or I'm going to do the APs that are going to be mounted in columns or pillars or against racks. Then we can differentiate them like that. If I keep going down the options, we have the scale. We learned this week about the GPS coordinates and the home marker. We learned about since the beginning, about walls and attenuation objects. We learned all of these options about aligning floors, creating the buildings, about changing the heights of a floor, the thickness and attenuation index of the slab in between floors. We dealt with scope zones and exclusion zones, what Ekahau calls a coverage area or exclusion area. Here they're called scope zones. We're going to do capacity today. Access points, we spend some time in it, just adding access points, changing the characteristics of the access points, if they're mounted on the wall, if they're mounted on the ceiling. We will play more with this because once we get to warehouses, we're going to be playing with more of these options. Then we also, in last session, we spent time adding an MDF, IDFs in different locations, adding wire clients and playing with PoE budget, adding phones and cameras and adding different devices that you plan on a network are not part of Wi-Fi, but they're part of sucking up power out of switches using switch ports. And then here you can start planning for all of those, okay? Getting power details and port counts and backhaul, fiber optics connections in between closets. That's another feature apparently they added recently. So what we have left, and we have touched a little bit on, is the client view. If I select this guy, well, let's actually do capacity first. If I go to capacity, I can create a capacity zone. So there is not one defined right now. So if I define one, let's say that this entire area up here, I just drew a box in this capacity zone. Let me just draw another one here. Come on, come on. There we go. I have these capacity zones. So let's say in this capacity zone, I have by default, it added 50 phones and 50 MacBooks. Let's just say this is the conference area. And let's say I have 50 iPhones, 50 MacBooks. Let's add, I don't know, 100 Android phones. Okay, here's the reality about capacity. It cannot be calculated. I don't know, Ekahau has it. It's always been there since the beginning that you can just create areas, add devices to that area, and then the software will put more emphasis on designing for capacity. But here's the thing. There are many other factors that are not considered. For instance, I have this other capacity zone. Let's see if we are looking at this one down here that has 50 and 50. Let's make sure that the one in there, come on, come on. My computer is doing the again. Let me just close more stuff in here and more stuff in there. And let's close this stuff. And let's close this. And let's close that. And also this. And what else? Okay, that's it. So here's the thing with capacity. If I add, let's say, devices. Let's say this area, I add 500 iPhones. Okay. Let me refresh this because I don't think this one is applying those numbers. Now that we're looking at capacity, this is not applying that stuff. I just added, say, a 0 in there. Okay, I have 500. It should be changing these numbers in here because now that I have the access point, see, if I have this access point, now it has the channel 6 in 2.4, and happens to be 149 in 5 and 149 in 6 gig. If I click that channel, then I have the options to not have the channel change dynamically, but to change manually. And I can just come and either turn a radio off manually or just change the channel. I can say, yeah, I want this guy on channel 1. This would be if you are tuning things here manually. If I do it that way, then that guy is just change, and that's how I turn off and on radios. Notice those numbers below the channels. Those numbers are the number of devices that I would have on each radio. So basically, let me go back to capacity. Let me come over here to these zones. Let me just change from this zone to that zone. See, I defined 2 zones in here. Let me hide. See, now that's when we want to hide all these walls and attenuation areas and stuff, because we don't need to see them right now. So let me hide network equipment, cables, and all that stuff, just to clean up the work area a little bit. Let's add attenuation objects. I don't need to see chairs and all that stuff. I don't need to see raised floors, low floors, and maybe I don't want to see a walls either. Okay, so all I have is the capacity zones, and I have the nodes. Let me add these nodes too. Let me hide them. So all I have right now is these guys. Let me make sure that I indeed, I have 2 capacity zones. We're going to have to call Jerry. Okay, how do I then select? Just come over here and select this area. Okay, and how about if I select this area? I thought I applied more devices to one of them. Okay, let's just select this one in here. Okay, and then let's add devices to it, and let's see if it applies. There we go. I added 500 iPhones. Notice that the numbers change dynamically. And here's the problem with this. And this is why capacity cannot really be calculated. Yes, I added devices. And then, yes, the software. And this is not just Hamina. Ekahau does it too. You add devices, and then it does the math and say, like, if in this area, because watch, if I select the coverage of this access point, that means that access point is in this area, okay, covering that area. And this guy is covering that area, and this guy is covering this area, and so on and so forth. What it does is, in that grid that the software created since the beginning, when we say that this area has 500 iPhones and 50 MacBooks, it just distributed them. And then it's like, yeah, I think in this access point, based on the signal strength and the area it covers, it places those devices in that grid evenly in the grid, as if they were holding hands like 1 meter apart from each other. And then it said, like, whatever AP is strongest in this area is going to get, more devices. This guy is going to get those many devices. And it says, like, yeah, right here, there will be 21 devices in channel 11, 113 in channel 60, and 43 in 6 gigahertz. But the reality is, this is not a decision that the access point made. This decision is done by the client, and we don't know where the client is. If you're, let's say, sitting in this area, nothing guarantees that you're going to join this AP. You could be joining that AP or this AP or that AP. So this is just calculating, assuming that things are going to go one way or another. If I add then 500 MacBooks, see right there? Then it goes again, blah, 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 does math, and then just increases numbers everywhere. What if I have 2.4 turned off? What if the SSID that I'm going to be using is going to be only in 5 and 6? So there are many factors in here that are not being taken into account. And this is why capacity cannot really be calculated, because one, we don't know where clients are going to go. And here we're not specifying what SSIDs are we going to be used and how else are we segregating the network. Gurpreet.
Yeah, Fernand, I think you have a great point. So I think we had the same feedback for Ekahau. So what they have done is, you know how the desktop version had the option of different iPhones?
Yeah.
Because you remember how you explained before that they're not even calibrated. Plus, you don't know where they're going to connect. So the only thing Ekahau is doing now with the online version is it only does clients per radio. That's the only capacity they do. You don't have iPhones or all that stuff anymore.
Okay.
That's one thing. A second thing, I think, what was a feature request. What we did was we said you can also ask how many, when you do that calculation, Because normally when you're doing a design, you're not going to consider 2.4 as a capacity, right? So you don't use 2.4.
Uh-huh.
So we usually say 0 for 2.4, and the two bands we put the. So for example, by default, you can have 30 associations per radio, and you can modify that also. So that's
Okay.
the way they have changed it now.
Yeah, and the that always was there on the desktop version that you can just say yes. Actually, in the past it was even worse, but yes, having like how many devices per radio am I planning on? That's something you can also configure in your controller. Say like I'm going to allow 50 devices per radio or
Yep.
70 devices per radio. Then you kind of like try to match that, but then the decision of joining
Is with the
5 gig
client.
or 6 gig, it's still up in the air. You don't know what's going to go where. Uh,
Exactly.
Back in the day, Ekahau had the option that you could say, like, I'm going to have, let's say, 50 computers. And then you could go into each item and say, like, and this computer is going to spend 40 minutes of every 8 hour period doing email and 60 minutes doing web browsing and 40 minutes and 1 hour doing this. And see, and there's like, who's going to calculate what each device is going to be doing every minute? It's like, that's just impossible. And you don't know how they're going to be at. So there was so much in it that the best way was just to get rid of it. Like, why do you even calculate like what people are going to be doing every minute of every hour? It's like, there's no way to do it. Wally, what you got?
Yeah. So, what if like when we like eliminate some data rates and reduce the power of the access points, especially like for some areas like at the sorry, for the conference
Yeah, that,
of conference room,
yeah,
like I prefer like to minimize the data rates and reduce the power of access point as much as possible. So I don't want to have a sticky client to the access point at the door of the conference.
absolutely. Yes, because you don't make those areas smaller, not just by saying how many clients per radio. Some people go by reducing the power, like to make the area smaller. Because the bigger the area is, the more chance. I've been in offices where one access point had the power too high, and there were clients all the way out here connected to that guy, and there was another access point in the area that had like three clients connected. One AP had like 60 devices connected, the other one had three because the power was low on this guy. See, let's just do it right now. If I change this to, I don't know, let's say 2 dBms. It's still, this is such a small area, it's hard to demonstrate that. But then just move this guy over here. This guy covers a smaller area, then it's possible that less clients are going to associate with it. If this guy covers a larger area, very likely that clients are going to associate to the guys that is stronger in the area. But the decision of where I join, the decision of where I go, it's something that the client does. We cannot calculate that. We cannot uh, uh, precisely and with accuracy, do a capacity calculation. But yes, the software, Ekahau does it. I don't think CEDOS does it yet, but Hamina does it. And yeah, it helps and it gives the software more variables to calculate all these different quantities of devices and the amount of radios and coverage and all the stuff. Yeah, it does a lot of math and gives us an idea. But then we're not going to get, so in capacity, like if it says the capacity is exceeded and it says that, there are 32 devices on this radio, 219 on this channel in 5 gig and only 96 in there, that balance is also just the software doing math based a little bit on some of the algorithms that are used. And let me tell you why, Gurpreet, the devices in here are specified. iPhones, okay, will have a list of decisions that they post and say, like, iPhones prefer wider channels over narrower channels, and they prefer 6 gig over 5 gig. And then what they've done, and now here's when we add this little guy in here, is that if I drop that client in there, and this is also an assumption, okay? don't take this for granted, because here's one of the problems, and that's the same visualization as in Ekahau called associated access point. It says that if I'm here, I'm going to associate to that AP. Again, that's just an assumption, because who decides where to go? The client. And it is possible that as soon as I enter the door and join the network, maybe I'm not going to join that AP. Maybe when I receive the beacon and it showed in the BSS load information element, like I'm on channel 149 and I have 219 devices connected. Maybe the client is smart enough to look at that field and say like, yeah, you're the strongest AP, but man, this channel is saturated. You have too many clients connected. Maybe it's going to look, let me just open Wi-Fi Explorer Pro 3 in here. And let's probably open, yeah, because there's not much in here. Let me see if I have another file we can look at. Let's just look at this file. See, like this one. It may show that there is, let's open this guy. See, there's 5 gig and 6 gig channel utilization at 1572 and the number of clients connected. If the client can analyze these fields and show that it has too many people connected or the channel is highly utilized, maybe that client is going to join another AP. But just for you following this exercise, the tests that they've done based on how devices roam and based on how devices choose where to go, as this guy moves around, see, I'm just dragging this little man around. Oh, and I can change that for a walrus. Ooh, guess where I learned that? You just press the letter W and then it becomes a walrus. So that guy, of course, walruses don't use Wi-Fi. Let's just change it back to a man, because man do use Wi-Fi. Happens that as I move and the signal, notice the coverage says, you know, neg 50, neg 45. If I get closer to the AP, and then the data rate, and it's just calculating SNR based on the signal and some noise that is defined somewhere, and it's just doing math calculating, and then notice that it shows candidates. The little lighter line that you see, the dark blue, that's where I am associated, assuming the client associated there. If I grab that guy and move it around, next 70, next 71, next 72, next 73, and next 75, it moved. It jumped to that AP. That is assuming and based. I've been to Jerry's house and he's got the setup in a way that one AP goes up, one AP goes down, and then tests the roaming of devices. And he did a presentation in WLPC, I don't know, last year or so about roaming wars. If you haven't watched that video, watch it later. And then as this guy moves throughout the area, notice that it has the 2 candidates. Those are the other lines, like those are the next strongest APs. But now I'm associated to this guy. And based on the coverage of this is assuming, you know, I'm on next 60, I'm on next 65, next 67, next 69. And then as I get closer in this area, next 70, next 71. And as I enter this conference room, boom, I roam to that place, okay? Oh, let me see one thing. If I move, let's look at the numbers on this AP, 32, 219, and 96. So if I come over here, 32, 219, and 96. Capacity didn't change. Well, I guess this doesn't account for that. I thought it was going to say like, now I have 97 or show where I am. Now, notice that it says also where I associate. Like right now, it says I'm on 2.4. See, it's on channel 6. 2.4 at MCX that. Let me go away and come back. Now it says I roam to channel 5. I mean, channel 149 in 5 gig. And it says, let me go back. Let me go there and let me come back. Okay. So it seems to be roaming based on, I don't know what, because again, that's a decision that the
It's a
client
100% client decision. Yeah, I agree with you.
Yeah, so we don't know
Yeah.
what band it goes yet. Hamina is assuming that I'm going to one channel or the other. Nobody knows.
Yeah.
Simon, what do you have?
Hi, sorry. funny. So with Echo, when you do a capacity planning, it allows you to, as I said, choose specify how many laptops and mobile phones and blah 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 for the zone. And also you also allows you also have a specify how many what's the throughput for each device, like is it low SLA, high SLA, or whatever stuff. And then it gives you the capacity and say green or red zone for airtime or whatever. For Hamina, it seems that it's just number of devices, is it?
Yeah. I'm sure it's calculating all of those other things just in the background. You just don't have the control so granular as you have in Ekahau. Because in Ekahau, you can add more details. Is that true, Gurpreet, also online as it is on the, because you just mentioned that it's simpler, right?
It's simple. The one I put the screenshots on, Renee, in the chat. So that's
Oh,
basically
okay.
how online version is doing it now. So
Okay.
it does like if you don't, so in every requirement area will have a capacity that is done by the AI. It looks at the map and says, looking at the map, I feel like this is the capacity you have. But then you can edit that and add whatever you want to. Not that one, sorry. That was just the analogy I normally use when I explain that when you go to a coffee shop, different people choose different lines. I mean, that's just the way it is, and people are different, right? So that's
All
just
right.
something I use in class.
Okay.
Yeah, but I think there was a screenshots before that had those two screenshots from Akahau.
Ah, okay. Let me bring this guy down. Let me download him so we can share him here and save this guy. And
And I've also added the link to Jerry's presentation. That was a Phoenix in 2025. That was a great
oh,
presentation. Yeah.
thank you. Let me, okay, let's have his presentation here. Let's turn the volume down. I'm going, so it's in the chat too, and this will be carried over in the chat. And he explained, and he did some of this stuff in there. So based on this data was collected, kind of like when do clients jump from one band to another and which one they prefer, that data has been fed into Hamina to when we add iPhone, so when we add a MacBook or when we add an Android phone. Hey, didn't I change this to 500 a little bit ago? Here, let me make sure that I do have. Oh, it's probably this area. Yeah, that one's accurate. I was just now in this down area down here. Okay, here we go. Then the algorithm, the data that is using is gonna try to calculate and see where things go based on data from the devices, whatever they provided, that they prefer, stronger signals first, or if they choose whatever. But again, that's just making assumptions. We don't know where devices are going to go. Let me open the two files that you added here, because in Ekahau then, you had clients in 2, 4, 5, or 6, and
Yeah. So this is something I define, and then they have like low, basic, or high, and then you can customize it. Like when I say customize it, you can define that how many clients do you want per radio. So that can be also defined. So
okay.
generally, I keep my 2.4 to 0 because I'm not one of, when I'm doing capacity, I don't want to think that anything is going to associate on 2.4. So that's the thought process.
And the same thing could be done here, like for
Yeah.
watch. If I have 17 devices and I come here and turn this radio off,
Yeah.
now I don't have 2.4, and notice the numbers changing here. It just assumes that in this area, whatever clients will be here, then more will go there. Now, watch if I add another access point. If I have another access point, let's add another, what do we have here? Cisco, I don't know, what was it, 9166, I think? There we go. Let's add one of those APs here. Watch the numbers. See, it takes numbers off of this AP and then add to that AP. What if I add another AP here? Then it will, and then that's math. Like, okay, then I'm start easing, making the load less on those guys. It's still marked as red, saying like, yeah, capacity is exceeded, man. If I add more APs, and again, I'm just adding APs to add APs because this is not design. I'm not designing, properly here. I'm just showing we're working on capacity and roaming. See, and this is just the client estimating where it goes based on the decisions that some of these clients make. And notice that this client is like in 5 gig everywhere. Let me see. And let me go over and just say, oh, because I don't have 6 gig capable. If I say this guy can do 6 gig, then as I move around, let's see, 2.4. Did it apply that? Let's see. Yeah, it's in channel 69. It's in channel 149. So now that I say, oh, this is an iPhone that can do 6 gig, then it's like, oh, then I'm going to roam differently now. It's mostly on 6 gig. See, it goes from 165 to channel 5 to channel 85. So it prefers 6 gig everywhere I go. But if it's Wi-Fi 7, I wonder how that's going to calculate this. That's another thing just added there because you can do it, but that doesn't mean you're going to be, when you're associating Wi-Fi 7, you don't associate to one radio, you associate to multiple radios. We'll talk about Wi-Fi 7 in another session. Okay, so this, I don't know. I didn't trust the capacity planner of Ekahau. I do not trust the capacity planner of Hamina. It just cannot be calculated. You can calculate channel reuse, but that's how capacity gets calculated. How good of channel reuse do you have? And then if we switch to the visualization of not coverage, but interference, now we're going to see where we're going to have lots of like multiple APs in the same channel. 2.4 is saturated. If I move to 5 gig, looks better. 6 gig looks better based on the distribution of channels and the channel configuration that I have here. Of course, I am enabling all the 2.4 radios with 1, 6, and 11. That's just not possible to not have interference because it's just going to be everywhere with 3 channels. And then here you set up to what channel width you're going to use. And based on the number of APs you start adding, it dynamically switches to narrower channels. That's how you're going to get capacity, is by the ability of having frequency reuse. And then here you can just enable and disable whatever channels you will or will not use in this plan. Wallet!
Okay, does Hamina like recalculate the power for access points, like something similar to RRM?
What's the question again?
I mean, I'm asking like if Hamina like in the capacity designing, like adjust the power of access points, like something like, for example, RRM.
Nah, well, I'm sure there's something of it behind it, but I don't think it does it the way the controllers do. And RRM, that's another thing I don't trust, man. I don't believe in RRM entirely because I've seen so many Cisco or let me just give you a concrete example. I went to a warehouse, do a survey, and then realized that pretty much the whole place was red, like the signals were really bad. The APs had directional antennas, like the really narrow beam, the Axel Text, like the one I have back there. See a white box? That's an antenna right here. Then I didn't have the transmit power, because if I come over here, it tells me what the transmit power is if the AP announces it. And in that place, they were not announcing it. So I didn't know what the transmit power. I thought the antennas were plugged in wrong. I got up there on a forklift and then realized everything was good. But then finally, when we got access to a controller, realized that every single access point was at 2 milliwatts. Just like, why? Because RRM sees the other APs and start going down, It was a setting that by default says the lowest power that I want to use is like -10. And then it just started going down until it's just like so weak that clients were not even hearing the APs and having a bad experience. So even with RRM, I've seen, let me just see if I have the 1 AP per classroom in here. 1 AP. Let me get out of this stuff. Here, let me in here. Let me bring up this other window. Let's see if I can find my 1 AP per classroom. Oh, stupid Dropbox stopped working here. Let me make sure. I'm gonna find that file here somewhere. Let me go to Dropbox. And let me 1 second. I will download a file. 1 AP per classroom. Let me download this file. Let's put it on the desktop. I have a chicken that make noises like a rooster. Like, okay, let me then open this guy in here. The downloads. There we go. Okay. This is why both RRM and the auto planner. Let me just share my screen again. Give me 1 second. Okay. This is a survey that was done in a school where they have the 1 AP per classroom approach. If I go to inspect and look at one of these buffers in here, watch this. Come on, come on. What's wrong with this picture? Let me just actually get on this side too. Okay, let me hide this guy. Okay, what's wrong with this picture? That's when I ask a question and any of you answer it. Don't you all talk at the same time? That's kind of confusing.
Some of the APs are on the same channel.
A lot of APs are on the same channel. What else do we have?
Next
We
channel
have
width.
Not using
different
DFS.
Yeah,
channel
like
widths.
high interference there.
20s
too crowded.
and
At
40s.
149.
Yeah, 20s and 40s and 80s. Okay. Everywhere. It's only using Uni 1 and Uni 3. That's it. You know what this is? RRM. This is it. And I asked the guy at the school and say, hey, why are you not using any DFS channels? And you know what he said? He said, I don't know. They told me that Cisco Meraki would automatically configure and tune my network with that RRM thing. And I asked him, and why do you have 20s and 40s and 90s? You know what he said? He said, I don't know. They told me that that dashboard thing is going to configure my network because RRM is the best thing I can do on my network. Like, not really. So these are the controllers making decisions that are, I mean, I may not be an expert when it comes to Wi-Fi, but I can see already there that, yeah, there are things I can do better. I'll just place this on 20 megahertz wide channels and just distribute them everywhere. Okay, so this is RRM. RRM ups the power, RRM downs the power. Here's the other thing. Here's the evidence of that. Watch. If I select, let's say, I don't know, one of these access points. Let's say this guy. This guy, oh, power is in dBMs. Let's change this to preferences and change this to milliwatts. Let me close this guy and come back and select one of these guys. Notice this guy is at 251 milliwatts. Okay. Like, wow, really loud. These other guys, let's see if I come over. This guy's at 32. Okay. And there are some of these guys. Let's see if we can find one. 13. And there are some others. 251. Let's see if we can find one of these guys. 25, 200, 13. How about in 2.4? Let me just look at some of these guys. 3 milliwatts. Why do you have some radios at 3 milliwatts and others at 251 milliwatts? It's just like the gap is huge. If you don't tune RM correctly, it's just going to do stupid things. See, and I don't know if it's because it's Cisco Meraki, but Merakis work great if you, and that was, of course, nowadays is better, but if you have, let's say, a McDonald's, and then you have one, maybe two APs, and then half a mile down the road, you have another McDonald's, and then they have one or two APs. And then it works great because from a dashboard, you can manage and control and configure thousands of them, on the dashboard, and it's good. But when you get 3 or 4 or 5 Cisco Merakis under the same roof, they just do the stupidest thing if you don't tune it. Okay? So it's hard to match. Go ahead.
Yeah, I mean, like I'm looking to the technology. It's .11n, so maybe I'm
Yes.
mistaken, but I think it might be a good decision, like to reduce the power of these access points or even eliminate it as much as possible. It's .n, so .11n access point.
And what does that have to do with that one AP is at 3 milliwatts and the other one is at 251?
I mean, like they are trying to eliminate the access point as much as possible. Maybe I'm
Well,
thinking
the
in it
thing,
in the
look,
wrong way.
there's a problem with one AP per classroom. If you have one AP in this room to cover like that room, that's 2.4. This is 5 gig. This AP can be seen at neg 85 or stronger. Pretty much, let me just bring this guy to neg 85. Pretty much in the entire school, I can hear that AP. How about this AP? And how about that AP? And how about this AP? So if one AP can be seen in the entire school, this is why those algorithms are just struggling to keep up, because I don't know where you are, but I can hear you. So if I hear you on the same channel, I'm going to lower my power. Oh, I can still hear you and hear you and hear you and hear you. Because if I have 24 APs in here, 24, see? One AP per classroom. If I have 24 APs and one AP covers the entire school, then in 2.4, since 2.4 is turned on everywhere, how many channels do I have in 2.4? I only have 3. So if you do a math and just cut it straight, then you're going to have 8 radios in channel 1, 8 in channel 6, and 8 in channel 11. So you're going to have interference everywhere. And in 5 gig, if you put them all in 20 megahertz wide channel, then you're going to have one AP per channel. They're not going to see each other and stuff. But they're using 20s and 40s and 80s. That's why if I switch to my interference visualization, I have interference in 5 gig. I have interference in 2.4. Why? Because they're just too much coverage for each access point, even with some of them at 3 milliwatts. Let's just try to find one of those that was at 3 milliwatts. Let's see if, let's look at this guy. Let's go to inspect. Gurpreet, what you got?
So I think, Pranay, I agree with you. And I've seen the similar thing with Meraki originally when they came up. If you turn on RRM, you will see power between 24 dB to 30 dB. That's always what they're going to keep. So and even Aruba did the same thing. They would always, out of the box, if you use RRM, channel width always be selected as 80 megahertz. Doesn't matter if you're in downtown Toronto or wherever you are. So what I started to, and another way I noticed was I was working with a warehouse where they said, oh, do you have APs? I have APs, but I don't have no signal. It's because the APs were on the top. They could see each other well, so they reduced the power with RM, and you don't have power here, but if you do like this, then you have signal, right? So I think generally best practice that I have been following is on 2.4 gigahertz. I'll enable RM, but I'll say minimum, maybe let's say 6, maximum 9. And then on 5 gigahertz, I'll say minimum 12 and maximum 15. So give them like a 3 dB window to kind of go up and down, and that has usually worked better. And channel width I always like to keep consistent and don't give RM that option, because otherwise, as you rightly said, it will create that 20 40 80, and that causes a lot of OBVSS, right? So
yeah, and I'm not saying, you know, RM is the solution everywhere or that manual configuration is what you should do. It changes depending on the environment, depending on the vendor you're using. Some have better algorithms than others. But if you don't tune RM, then it's just going to do whatever. You just have to set, you know, what channel widths you're going to be using, what are the minimum power levels, what are the maximum power levels, or else it's just going to go as wide as it can. That's why you end up with deployments with 160 megahertz wide channels, and then using just Uni 1 and Uni 2. And I've seen that in a few places. And then it's like, yeah, no wonder why you're slow. You pretty much have every access point in the same channel. So watch this. That radio is at 3 milliwatts. I'm looking at 2.4. It, even at 3 milliwatts, I could see that guy everywhere in the school. See, lowering the power is not going to fix anything, and it just does its best, but then it depends on the construction of the building. So there are so many things, so many variables, so many items to consider that's why this capacity planner do not take this as the absolute answer for capacity, and that I'm going to need this many APs because Eka House said I need this many, or Hamina said, or I don't think Cirrus can do capacity planning yet. I don't know. Once we get to it, we will learn it together because I know a lot of things have changed. All right. So questions or comments up to this point? We kind of like talk about capacity. Yes, it would help you identify something. I'm sure if Jerry was here, he will give us some more pointers and things that I'm not saying. And it's not that I'm biased to, I don't like capacity plans. Like, it cannot be calculated. Okay. Same thing with roaming. Yes, this will kind of like give you an idea based on the signal strength and the type of device I'm using and the capabilities I'm telling it has, and the worst link, downlink, or uplink. I can just play all I want. But that doesn't mean that if I have a guy in the real side in here walking in that direction, is going to run from that AP to this AP when it gets here. It just doesn't happen that way. We did that test at that convention center with Mr. Parsons, and 3 of us walking the same path. We were roaming different APs at different times in different locations to different bands. We were roaming in 5 gig, other going from 5 to 6, back to 5, back to 6, to another 6. And then the other one was like 6, 6, 6, 6, 6. It just stayed in 6 all the time. Once or twice roamed to 5 and back to 6, and it gave priority to 6. And then we also went in with another device that was 5 gig only, and it roamed at different places. It just, that's why we cannot tell people where to roam. We cannot design, because people say, like, I want this corner right here to be my roaming area. There's no defining a roaming area here. I want this AP in the hallway because when people walk out of the office, they will roam to the AP in the hallway. Oh, really? Who decides that? It's the client. It's possible that we walk out of a room and keep connected to a room, walk all the way down the hallway under 2 APs, walk into another office that has an AP in there, and we're still connected to the conference room that is 30 meters away. Okay. So, yeah, these 2 options are there. You can use them and kind of like get an idea, but I don't know. I wouldn't trust it like blindfolds. Like, yeah, that's what it says. That's what, that's just that. Simon, what you got?
Sorry, funny. So, now that you mentioned about the work that you did with Keith, in Canada, how did you plan for that capacity for that gig?
Channel reuse. We just try to keep the coverage areas of each AP using directional antennas, trying to keep it concentrated to a specific area. That's why bringing the APs down low and having them just cover a specific area is better than having omnis out there. Once we get to our warehouses here in the next few minutes, we're going to start using bigger spaces, and well, actually, we're going to design in some smaller spaces. But let me just, before we move out of this small office, because we've been playing since the beginning with just this office. It's a 3-story building. And then we've just been learning all of the concepts. Every item in here now we have played with this week. Now let's use what we've learned in here and then use this in a warehouse, okay? So yeah, how do you calculate capacity? By just frequency reuse. You're not gonna get capacity by adding more APs. You're gonna get capacity and higher number of devices successfully connected to the network and having a good experience, not by adding more APs, but by being able to reuse channels. Meaning, if I have, let's say, channel 44 in here, see that guy's on channel 44. Where else can I use channel 44 that doesn't see this guy? Of course, this is one small office and there's just a few APs. I can place the APs on different channels and they don't see each other. That's why when I come over here and 5 gig to channel interference, it's like, yeah, I don't see any interference because you have less access points than channels. If I were to start adding APs like crazy, here, let me just for the heck of it, let's just start adding access points. Okay, so when I drop it, it finds other APs in the same channel and then it switches and now there's no interference. But watch, there is a point when you add so many APs that unavoidably we're going to have channel interference. How many do I have on this floor? Okay, I'm on 5 gig. I start seeing some, see? And now I see more interference. Why? Because once you have so many APs, you just add more. Hey, this is the deployment that every salesperson wants to sell, see? And one AP every 5 meters, man. High density. Now, why is this? How is this removing interference from this guy with so many APs? Here, let's just add one in every office. Add one in the bathroom, on the stairs, one down here, another one here, another one there. Is it lowering power? I don't think so here. There's just no way you're only going to have, well, 2 to 3 on each one of them. So, see, just by adding APs, you don't, I mean, capacity is probably looking better, even though we have like 1,000 devices. This is just an exaggeration because we have such a small space. Although I've seen places with lots of APs in a small area. Now, Hiten, you're asking about RxSOP. Well, kind of will help. RxSOP, it's just that that's playing with the threshold of if I hear somebody at, let's say, -82 or stronger, I will stop. With RxSOP, what you're doing is telling it like, okay, if you hear somebody at, let's say, if you make it more aggressive, if you hear somebody at -78, you know, then stop. Or changing it the other way. If you hear somebody and, you know, just basically, when will I transmit despite of me hearing somebody else in the same channel? So this will help, but I don't know. Jake Snyder did a presentation about RxSOP in, I don't remember if it was Budapest or Prague or we were back in Lisbon. I don't remember. Just look it up.
Keith and I think Keith and Jake also had a podcast, I think, on the heavy
Just
RF.
recently.
Yeah.
Yes.
That one was good too, actually. They did touch on that stuff. So which was actually.
But the other presentation, he spends more time specifically talking about RxSOP. So you gotta be, I mean, that's another lever that you don't want to adjust too high or too low because you may cause other problems. So as Ned says, just be careful. RxSOP is one of those options that is out there, but you got to be really careful when playing with it because you cannot make the decisions on the APs better just by moving that up or down. Depending on the environment, that's one of the things you have to study and make sure that you understand it and that you test it in your environment to see if clients like it or not. Okay. Now, let me grab this guy. If I select, watch this. If I go to edit, and if I select everything in here, I have 47 items. I have 43 access points, one zone and 3 capacity zones. Since I'm not visually placing walls in there, let me add them. If I add slope floors, if I add raised floors, if I add attenuation objects, let me do that selection again. If I select everything in here, notice that in here, it tells me what is selected. 43 access points, 176 walls, attenuating objects, everything in here that I have selected. So I can, if I just want to look at access points, notice that it highlights the access points. And it says, oh, I have APs in the ceiling, I have 3 different colors, and I have 2 different models and 2 different vendors. So if I click on one of these, maybe I say like, hey, show me just the Aruba APs. Or I can say like, okay, out of the Aruba APs, which ones are different models? Well, this is only one model, so it shows what those are. I just choose the other model in here. Let me just go back to, let me go back to, they're all selected now. So do I have to select the whole thing again? Let's see. And I just come to access points and select Cisco guys. So they're all in blue, and it shows right here where they are. And whatever change I make right now, let's change that from a 9166 to 9120. The ones with internal antennas, these guys. So now it changed those APs that I had selected from one model to a different model. And since this guy is only 2.4 and 5, notice that now the 6 gig radio disappeared. And now it just shows that, oh, since I don't have 6 gig, all of those clients that I have in the capacity one. All right, like Gurpreet, the clients that were on the 6 gig radios now got redistributed on the 5 gig and 2.4. So it just has like a harder time because it's moving those guys with less radios. Okay, I keep I think these are the Aruba 635 ones that I had added before. So I have a mixture of. This is just to show the concept, okay? And also the colors, because if I select the access points in here, then I can select out which color. Like if I want to just look at the purple ones. So like, oh yeah, there's one AP, that guy, it's purple. What do you want? Then I can just select it and do that one. I don't want to make that Aruba 635. I want a 735. And then I change it, and then whatever it is in this selection, it will change it. Same thing if I want to select different ones. Now, how do we apply this really in real life? Let me go to this project. Let's see if I have this. Let's see if this works. Let's see if I have everything in here. Man, why is my computer going crazy? And, give me a second. Let me get the right file. This is not it. There we go. There's this guy. There we go. Let me share my screen again. So this is what we've learned at larger scale. See, I have different APs, different colors. These lighter blue guys, if I select one of them, that's a Ubiquiti E7 campus, 2, 4, 5, and 6, mounted on the wall. It's actually mounted on a pole, on a post, at 3 meters off the ground, and it's tilted about 20 degrees down. We're just doing this tilt. We're going to learn about these directional antennas in the next session when we get to warehouses. These other orange APs are E7 campus, but those are APs mounted in the ceiling, like from the ceiling shooting down, like a shower. And they're at 7.3 meters from the ground. And this orientation is if the AP, because if I look at this E7 campus, look at the radiation pattern. It has a main lobe and it has side lobes like this. So if I change this rotation, because right now, this guy Well, let's actually look at these other purple guys. These guys in here, they are mounted on the wall, see, wall, at 3 meters from the ground, and they are tilted down at 20 degrees. So basically, those IPs are those APs. See over there? So they're mounted on the beam sideways on the wall at 3 meters. And here was the original plan, is to put them at 20 degrees down. We ended up putting those guys at 0 degrees, basically just going straight out like this, okay? And this, since that radiation pattern of that antenna is like wide like this orientation in here is doing this, changing the orientation, putting it at 90 degrees. Watch, if I have this guy at 0 degrees versus 90 degrees, come on, refresh. Let me refresh this. Something's going on, man. I think the whole week this computer's been acting weird. Oh man, which AP was that? Holy smokes. I'm not gonna remember which AP that was. Okay, let's change this guy from 0 to 90. See that the radiation pattern, the area it covers changes? Because the software allows me to either have the access point like this, or if I rotate it, it's gonna be more like that. So we are getting, by changing that 90 degrees, we're getting this side lobes, and instead of being left and right, they're going to be up and down. So covering a different area. In reality, kind of didn't make much of a difference, but in the software, based on the antenna patterns provided by the manufacturer, it shows that it makes a difference. Real life kind of realized that it doesn't really. Okay, questions up to this point. Let's start then. Let me create a new project here. And we're gonna create a warehouse. In Espanol, they call them nave, una nave. It's called a nave. United States, and let's just specify here that we're gonna be doing a warehouse. Save. Now we created a new project. I'm gonna select the floor plan in downloads. I have that folder called maps. There we go. Then let's start with a little one, okay? Let's start with these almacén racks. It's just a couple of racks in here. And that's it. Very simple, very straightforward. What do I do first? Well, I give it the scale. I do a scale. Remember, in here, these wiggly lines means that AI kind of like said, yeah, I think this is about this much. Well, in here, it says this is 18.4 meters. So if I'm at scale and I say that from here, click and down there, yeah, it's definitely not 18.4. So the scale it got, wherever it got it from, like, yeah, you didn't get it very right. So this one is 18.4 meters. Hit enter, set scale. And then now this is not a wiggly line anymore. This is a straight line. With that straight line, now I say like, yeah, now the scale is good. Now, if I go to walls or attenuation objects, notice that the walls, it said like, yeah, I think this thing on the outside are those walls. If I switch to 3D, it found some windows in there. Those are not windows. Those are actually doors. We can go and change that. And then, sure, let's say this is brick. Oh, and look, it did the racks for me. Holy smokes. This is design of Wi-Fi in less than 2 minutes. So we're in walls. Let's say this area, this blue area, see if I hover over, it says, oh, yeah, I think those are windows. Like, no, those are doors, metal doors. And if I select this guy, say, yeah, I think that's concrete. Okay. They say, no, I think that's brick. Then if I say auto draw walls, that's it. I'm done drawing walls. See, if I go to 3D, there it is. It drew the walls and the doors.
There is a
Okay.
door also in the middle, I believe.
In the middle, yes, this one right here. So if it missed that one, here's what I would do to just manually see if I switch. That was an auto draw. I would just come over here and draw, and then let's say we find a door metal. Let's put another one here. Click, click, right click, just double check, and there it is. Now, if those are higher, then I can just go in and change the settings for those doors or create a new one. We learned that in the previous session, how to do it. It's the same thing. You just create a new one. If it's taller, then now if I move to my attenuating objects, it also says like, yeah, I think these are racks and they are 8 meters high. And if I look on 3D, those are the ones we just saw. And I can make these walls transparent. That's when the transparency in 3D works. Let me make sure that I have in here for full building propagation, auto select, simulation. Okay. Display heat map client height. We'll play with this again. Opacity. Make sure this is the, this is opacity of the floor plan and the signal prediction. So if we go back to the walls, just go back.
From all layers, you can see the transparency option.
It was there? Did I miss it?
If you click 3D, when you click the 3D and all,
okay,
and the layers, like these layers, like the building, the whole building.
Global settings?
No, like
the
beside
layers over here.
Yeah,
The transparency. Okay.
Yeah.
So this one will show us better. And you can also set up the transparency per item. Like if you go and do a brick walls, just the brick walls in here, just go to walls. If you go to the settings, you can just specify that in 3D, make this guy transparent. But as Jerry showed us, it's better just doing the whole project, or else you're going to have to be doing transparency on all of them. Let's just try to change this and see what difference it makes. That didn't apply, didn't it? Didn't seem to like it. Here, let me go back. Let's go to walls, brick. Didn't I select it? Oh, I didn't select it. Oh, I didn't save. That's what happened. If I save now and go to 3D, even with this button unselected, the walls are transparent, not the doors, because I would have to go to the doors and do it manually. So that's why it's better to use here the sandwich and they say transparent in 3D, and then everything becomes transparent, doors and windows and stuff. Back to where we were. If we are in attenuating objects, it detects those racks, and those racks look good to me. I can just say, all right, leave it there. And I auto draw, and I didn't have to draw anything. It automatic, well, the only thing we did was this door. But then other than that, it did the walls and the racks automatically. And that's it. It is no different than an office. We started with an office, small objects. An attenuation object is a desk, is a chair, is a futon, is a filing cabinet. In a warehouse, the attenuating objects are going to be tall racks. The attenuation objects are going to be big piles of pallets of stuff. You can create same way as we created desks and stuff. We can just come here to attenuation objects, go to the settings, and then duplicate whatever I have there and create a new one. For instance, warehouses, and you know what? Let me just do this. Let me select this wall and delete it. Now, if I go to 3D, I can just go and look at stuff in here that way, okay? Even with transparent walls, you still have that on your way. Warehouses are these places with a high ceiling. Let me just go back over here and let me go back to a different place. Let's go from Toronto to New York. Let's go from Toronto to New York. In warehouses, then you have high ceilings, you have a lot of obstacles. You have the volume on this one. There we go. Then you have lots of merchandise. You have less space to put your access points. You have areas, specific areas that you need to cover. And the attenuation objects, so look at those guys. The access point is all the way out there with omnidirectional antennas. Come on. There are cold storage areas. There are just regular warm storage areas. There are these tunnels. See, in between racks, there's going to be these places where the cards can go through. So how do you design this? Very simple. We learn how to do that. That will be creating an attenuation area that doesn't go from the ground all the way up, but it goes like halfway up. So how would we design that in here? Let's just do it right now real quick. I'm going to the attenuation objects. I'm going to go to settings and I'm going to duplicate server rack. And I'm just going to call this, I don't know, let's just say server rack high, you know, the higher ones. And let's remove the shortcut. And let's just say that if the racks are 8 meters high, then let's say the top of this rack is going to be 8 meters. But then the bottom is not going to go from the ground up. It's going to go, let's say, from 5 meters high. Okay. So it starts empty, empty, empty at 3 meters from at 5 meters from the ground. And then it goes up to 8, the top of it. So let's make this a different color. Let's make it orange. Let's hit save. And now let's draw one of those guys from here to there. Okay, if I go to 3D now, voila! See, it's not that hard. You're just creating this effect in here. And if we remove the transparency, there you have it. We're simulating a rack and another rack that is suspended in the ceiling, kind of like this tunnel. That makes sense? It's the same concepts we've been playing with this wick. It's just a larger scale, higher ceilings, different areas. Now we're not talking about a 90 centimeter tall desk. Now we're not talking about a conference table and some chairs in a conference room. I'm talking big racks and big spaces. Nah. What else do we need to cover in here? Now we can start looking at the access points. Okay. Let me also delete these walls in here. Just go to 2D. Well, I can just hide them. Okay, let me make sure. Let me make sure that I'm not, why isn't this? Do I have anything selected? Control Z, Control Z. Let's just get rid of walls. Okay. Now, since we're just working on racks, oh, in 3D, it shows them even if I don't, yeah, let's just delete it for now, just for the purpose of this exercise. We're going to look at walls and delete them. Yeah. Thank you all. Thank you, door. I don't need you right now. There we go. Okay. Go to 3D. Ooh, now I have one big door in here. Let's just delete you too. All right. So now looking at racks, if we start adding access points. So if I need to add access points, if I placed an omnidirectional access point, let's use 40net. Need 40net guys here? Probably 231. Oh man.
We here.
Okay, so Omni, here we go. 231E. Let's use this guy. If it says it's at 2.5 meters from the ground, if I place this guy there, let me switch to coverage. it said that it covers this aisle and a little bit of the next one, okay? If I place another one in here, it says, if I select just this guy, it says that this covers this aisle and a little bit of that one. Why? Because it's simulating them at 2.5 meters of the ground. So of course, they're not going to be at 2.5 meters of the ground. This guy is going to be, let's say, at 8.5 meters from the ground. So it moves it up. Now remember this. The access point is actually not located where the circle is. Let me just come over here. Not where the circle is, but where the tip, this arrow is at the bottom, okay? So that guy is just like 50 centimeters above the tops of the racks. So this guy, I also want to move to, like, let's say 8.5. Okay. So now if I go to the 2D and the visualization of this guy, notice that it shows that it only goes there, because I'm looking at the visualization height at 1 meter off the ground. So I am basically, let me just add more of these access points. Let me add another one in this aisle and another one in this aisle. I just place it over here. So I have those guys really high. If I go to 3D, that's kind of like how it looks. But what that area down there at 1 meter of the ground doesn't seem to have much coverage. Why? Because the access point is high and there's that big area blocking it. So I could, this guy over here, okay, select it. Let me select this guy, just bring it down to, let's say, 4.9 meters. Come on. And I can even bring this guy and place it under this. See, if I place that guy under there, that's the equivalent of placing an access point here under that tunnel, okay? Now, if I look at the coverage, it shows that, yeah, down there, if I switch to 3D, now down there, it's very well covered, see? Versus how it was before, that it was up high. So here's the problem with having omnidirectional antennas in a warehouse, which unfortunately, that's where a lot of places you go, they're going to have omnis. Why? Because they're cheaper, because they didn't know any better, because they say, like, yeah, no, we've used them in other warehouses and they work great and they're less expensive. External antennas, they require mounting for the AP, a mounting for the antenna. They require cables and more stuff. So they try to go the simple route, the less expensive route. And here's part of the problems we're going to face. This guy says that, yeah, and you may look at it, say, like, yeah, that guy only covers that aisle. And this guy, if I select this guy, say, yeah, that guy only covers this aisle. And this guy, yep, that guy only covers this aisle. And it makes sense in here in the design. If I change the visualization height, let me switch to 2D. And let's change the visualization height to 2 meters. Let's actually leave this guy in 3D and let's play with the filling effect. There we go. I select just this access point, okay? It says at 2 meters, this is what I see. And this is where it gets extremely useful, because if there are places where the guy that scans the merchandise is not just at ground level, but goes up and scans up high, then you can see if that AP in that location is going to provide coverage at that height. About if I say at 3, at 4, at 5, at 6, at 7, at 8, and then at 8 meters, boom! At 8 meters, see, let's just put it down below. At 8.3 meters, that guy covers the entire warehouse. This guy, the entire warehouse. This guy, the entire warehouse. Well, this guy is under that area. So at 8 meters, this access point up high doesn't cover much. So if I'm worried about this guy and the coverage in this area up high, then maybe if my hopes is that this access point is going to cover this entire aisle. Even when guys go up and scan up here, maybe they're going to have a bad experience. This guy's going to probably cover it just fine. But if you want to look at the coverage for that specific guy, you just select that guy. But up higher, then it's not going to work. We're going to have to add another access point. Ashish.
Yeah, I was trying to change the height of the clients, but the way it was showing the green hue that was changing as you are increasing or decreasing the height, it's not showing up for me. What did you do differently?
I don't know what you're doing different, but I just went here to the global settings.
Yeah.
And then you change, this is the client height, okay?
Yeah, I mean, in 3D, I was just checking in.
And then make sure that this button, so if you go to 3D, you're going to have a different option in here that is called this. Oh, I think I have it in both places, like show the heat map at client height.
Yes.
Maybe you don't have that selected, then it doesn't show you the different heights.
Yes, sir. That's all the thing. Thank you so much.
You're not paying attention, huh? You were trying to do what I was doing, then you got lost. That's what happens. All right. Let me. I go back to here and enable this guy. Then it will show me what the coverage is going to be. Now, I did that test during a survey to show my students and show people why using omnis in these places, it's probably not the best idea because of that same reason. Let me go to the Dominican Republic. Okay, I went up. Watch this. High ceilings. Okay. I'm all the way up above the racks. Okay. And what happens is that when you're up there, there is nothing. If you have the access point here in the ceiling, which that's where you put it, because you put it down low, the forklifts are going to knock them down, then you're going to have visual line of sight of that wall and that wall. See all the way over there? And then if you come over here, that wall and that wall and that wall, basically, that access point, an omnidirectional access point up here, covers the entire place because there's nothing. Just waves going through, and merchandise doesn't go past this point. And if it does, the AP is still higher. Then using omnidirectional access points in these warehouses can be problematic depending on the amount. Right here, I only have 4 access points. Like I can use 80 megahertz wide channels and still be good. But why would you use 80 megahertz wide channels when you have a barcode scanners? Every time you pull the trigger, you're getting what, 8 bytes, 12 bytes? I don't know, not much. So there's absolutely no need for 80 megahertz wide channels in these guys. Omnidirectional ones can be problematic, but unfortunately, that's what we have in most warehouses. That's what I have to deal with. I don't know about you guys, but that's what I come across a lot. You go to a warehouse, they have omnidirectional antennas.
When I worked in warehouses, I used to have like 1 or 2 maximum omnidirectional antenna in the middle, and like use directional antennas at the side walls.
Yeah, but in some cases, the walls, there are no side walls because they have racks on the walls. Then there's no way to put them. So you put them down in the hallways with directional antennas aiming down. Let me just go to another place where we did have directional antennas. Was it Dallas or was it Austin? I think it was Dallas. Yeah, right here. So here's where I got up there and checked the antennas, and they were properly connected. There's the access point. Here's the antenna. These are narrow beam antennas that are aiming straight down the hallway. Okay, that's the goal. And there are others in there. So there's other APs and antennas. So they're not on the wall, they're here shooting down waves down the aisle. Okay. Questions up to this point. Warehouses, I mean, just think waves. Warehouses are just complicated environments because there are high ceilings. There are big, long hallways that you have to cover with lots of merchandise everywhere. And sometimes they don't have any merchandise on them. So the waves will just cover bigger, larger areas. And you have long distance to cover. The AP has to get there, and the clients have to be able to scan and still have good signals wherever they go. Here's where they had the power set too low because RRM just lowered the power so much that it basically had every radio at 2 milliwatts everywhere. So power was so low it could barely hear him down on the ground. So using directional antennas, let's just use them. Yeah.
When you use the direction of the antenna, do you calculate the beam width, the angle?
Yeah, absolutely. That's why you get directional antennas. You just have to figure out, and the vendors will give you the beam width. Like, let me just get out of this project. Let's create a new one. So this is a simple one because we're just adding, I mean, we're using all the concepts we learned this week designing offices. We're just creating bigger stuff, okay? Now, you know what? Let me show you something really cool before we move out of here. Let me delete this guy. Let me delete that guy. Let me delete this guy. So let's see how long these racks are. From there to there, they're 15 meters. Remember that place that, let's see, where is it? This place that Jerry shared with us, the guy that has all the libraries robbing Wi-Fi. Down here, out of the 300 items that he's got, I saw some warehouse racks. Hot desk.
You can filter from the top of the page.
Is there a search?
Yeah, you can filter them.
Where?
Go
Oh,
down.
right here. Yeah, let's just type rack. Search. It took me somewhere else.
No, that's not what I mean. I mean, like, close this one, scroll down a little bit.
Okay.
Yeah, okay.
Warehouse. Okay.
Type, you can still, yeah.
So warehouses, and then we have racks. Let's say this guy, 6 levels, dense load, pallet rack. It's not a pallet, just try to find one of those orange ones. Let me see if I have, because there are different kinds. These ones, I think these ones are the same ones we have in here. Hang on. That will work. Oh, it was the other ones in the Dominican Republic where they had this same kind. Dominican. There we go. Yeah, there we go. So kind of like this, huh? All right, so those racks become like these racks. So if I select this guy, I could, let me see if I can, this is one of the ones I can change. So it creates multiple ones, copy for Hamina. I thought you could specify the height on this thing. Hang on. Or is it, oh, you know what? I think it's on, let's see if Shuttle's got that. Where's the Shuttle stuff? Shuttle. So let's see if I come over here. Vehicle, creator, office, clutter, vegetation, people, object. I wonder if in here, because here's the other thing, you can create cars. And you may say like, well, that's silly. But look, if I have a forklift, I can specify the length of the car. Okay. It says, I don't know, 3 meters. That's long. Let's say 2 meters. Let's say the width. See, let's rotate this guy. Let's say the width is just like 1 meter. Let's say the height. So you can adjust the height. Snow cover. Let's see. Also, I can do trucks. See, here's actually something really cool because I can make one like really long. Let's say in meters. Say it's 15 meters. Okay. And let's say that the width, 2.2, but the height, just make it taller. And then I can also create multiple ones. Because in a lot of these warehouses, there is parking out there and you want to simulate trucks and trailers and have multiple ones of them. So I could, in here, just copy this to Hamina. Let me go over to Hamina. And let's just Control V. Oh, let me get out of here. Let me just Control V. And here are the trucks. Yes, you may, this is a small one, okay? We'll just do this in other places, but you can add forklifts and multiple trucks. I'll show you, let's see which one. See a warehouse like this? I can add all the trucks. See, I can add all the vehicles. There are vehicles in here. I can add the cars in the parking lots. I can simulate multiple trucks, multiple trailers, and then just paste all that stuff in here. So it helps. And also these racks. So let's just go over to the tool. But then in here, then I cannot change heights and widths and stuff like I do with schedules, huh? Or can I? But I just add this guy. Oh, this is just what's the height of this guy? Because it creates all of these elements. Let's just say copy for Hamina, copy it, and then let's go over to the warehouse that we had Nave, and let's just Control V and bring those guys over here. Ooh, and how am I gonna rotate them?
Actually, there's two ways to rotate it. I was looking at it yesterday.
Okay,
So
how do you rotate them?
okay, so let me share a link with you.
Let me stop my.
Okay. So yeah, okay. You can, the first way is to go to the Hamina editor.
You
I'll
wanna share
just
your screen?
okay. Let me share my screen. I'll share it. Okay. Can you see my screen? Okay, so from the editor tool,
Yeah.
3D object, yeah, you can just like copy whatever you need, like this chair, and let me bring this one here, and then yeah, go to this one. You will copy it in that
Paste.
one, load
Yeah.
object, so you have it there. You can like change the scale or do the rotation.
Oh, so I could do the rack on
Yeah,
on
that's
copy it
the
and put
easiest
it on
way. Yeah.
schedules, basically using both tools.
Yeah.
Okay.
There is not a direct tool. You have to like to do it, and also you can change the scale if you want,
Okay.
and
Beautiful.
then copy from yeah,
And then copy it and then paste it over there. Okay. So
exactly. How to stop sharing now?
Yeah, let me share mine. And let's see how that goes. Share. There's another antenna calculation thing that so Wallet, you pasted on the chat. Thank you very much.
Oh yeah, yeah. So, like if I had like a long aisle or something like that, and I want to have two direction antennas in front of each other, that was something like helpful a little bit to know how much coverage it will be like,
Mm-hmm.
or what is the down tilt I need to do in for both access points.
Okay, perfect. So this guy, so if I copy Hamina, but then I open it in Shettl's tool. So let me go back to 3D object editor, then paste it in here. Load object. Ooh, look at that. Sweet. Okay, now, so we want to change the rotation 90 degrees. It's 89 or 91 here. Can I just type it there? Guess not. I guess I have to be more steady. Here we go, 90 degrees. Oh, but then the scale is the whole thing, right? 1.25. Okay, let's just copy this and see what happens. And now let's go to, let me bring this guy there. Let's go to Hamina, and if I hit Control V, oh, beautiful. Look at that. Now it is 90 degrees. Of course, it's not, scale was not right. It would be nice
I
if
think
you
we
could
might be
group
able also to edit it from just the JSON script.
the JSON. Just tell
Yep.
it. Okay, let's go over. So right here.
Yeah.
Oh man, where do you go? Maybe I need to paste this somewhere else, huh? Yeah, let me copy this stuff and paste it on Xcode. What do I have? Visual Studio. Oh, I had Xcode open here. Create a new project. And let's, ooh, where do I go? Oh, this guy came up. Let me, oh, which one? Use a template for a new project. I don't know anything, right? Doesn't matter. Holy smokes. Testing system. It's complicated. Why don't you just let me create a project? I just cancel this. Oh, it just didn't let me do it. This stupid thing. Okay, let's just use this guy. Create a new project. And let's paste all that code. Oh man, that's a lot of stuff. Yeah, because you know what happens is that it creates a whole bunch of objects. Because in Hamina, this is not just one object. It creates an attenuation area that is from the ground up this many centimeters. And then there is another one that goes like this. And then there's another one in here. And there's another one in here. And another one and another one. So it's a whole bunch of little things stuck on top of each other. Watch, when I paste it in Hamina, see I have that guy and it's selected. Look what all of the items it added.
Yeah.
So it's a lot of work. So I guess getting it just right. I mean, I could just copy multiples of one. Let me just
Or you
say
can
show.
put some of them beside each other.
Yeah. You can just create the at least the length that you want, and then just put a whole bunch of them. But this will help you. Once you tune the right size and stuff, you can. I mean, this saves you a lot of time just drawing one and the other one and the different heights. But the thing is, once you create it over here, you can just replicate it, and I can just copy paste all this stuff. Like I can just select all of these, which they are selected now, but I can just select them, Control C, Control V, and then before, don't unselect it, just move the whole thing over. And now I just created another. Now, if I select these two and Control C, Control V, and place this guy over here, and then go to 3D, now I have racks created really quick. Isn't that cool? Really nice, huh? Okay. So now let's talk about the directional antennas. Let me go to a different project. Let me create, well, actually on this one, I can just add a map. Okay, and let's add this warehouse JPEG image. It's uploading, the map is ready. So if I come over here, there's a warehouse one. This is, give it a second, be patient, it's doing math. It should pretty soon. Dun, dun. Isn't that cool? That's easy. Look at that. Now I have the place. Of course, there's things we need to change because these walls are not going to be that high. Most warehouses are going to be something like, let's see, like this. You have the racks in one area, the docking area, that's where they have just pallets. They start getting stuff from there, bringing it here. So this is going to be low, that's going to be high. And those are the offices over there. See, there are multiple floors. Sometimes there's only one floor or two floors, and then more storage on top or nothing on top. So that's what warehouses are going to be. So you're going to have to design things differently. The columns, how do we draw a column? We learn how to draw columns over at the office space, okay? But then in here, I would have to come and select this and edit it and say like, no, you're shorter. You're not all the way up to the ceiling. You're just lower. But in here, let's just leave this guy as is. We put it in 2D. And if we give it a scale, is there a scale in here? There should be one. So it said that from here there, that's 20 feet. So let's switch from meters to feet and say this is 20 feet. Set scale. Now, if I go to walls, let's see if we can figure this out. So the outside says concrete, okay. There's concrete, doors, windows, heavy drywall. I guess these are the heavy drywalls. I could just come and edit and change these guys and see which material, but I cannot edit each one of these guys unless I come here and specify, okay, anything that is drywall heavy and change the heights. Guess we're gonna have to do that later, okay? Let's just import it. Let's just say that auto draw all the walls, and then let's go to the attenuation objects, and it brought all of these guys up, okay? Ooh, something on that auto import change, huh? Maybe let me just have this guy import whatever we have in there and see what happens. Because this one says, no, it says it's 26 feet. Let's just auto draw him. And let's go back to 3D and see what happens. Yeah, this is all short now. Or, let's see, we go over to our walls. Oh, let's create the building. Here we go. Let's actually go to the align floors, and then let's bring the warehouse in there. Oh, that's the other map. Yeah, we don't want that guy here. But this guy is not 8.2 feet high. This one is, let's say, 40 feet high. And now if we go to 3D, then it changed the height of that. The walls keep being really low. Whoa, what did it do? Let me remove this floor from here. Let's just delete that map and leave only this guy in there. Let's make sure that it doesn't have any other floors. Let's look at the 3D stuff. Now we're back to where we were. Okay, everything is at the height. And let's just use this to play with directional antennas, okay? If we go to access points, now we know if we add an omni access point in here, this guy is at 8.2 feet from the ground. Let's just bring that guy higher and change the settings. Let's just move this to be at just 3 feet from the ground. Of course, it's not going to be down there. Let's move this guy up high to 35 feet. What's the height we gave this thing? 28 or something? So there's the access point. Now we saw the effects that these guys would have once you have those at different heights and the visualization height changes. Then up there, that AP is going to cover the entire warehouse. That's this experience. When you are all the way up high, having omnidirectional access points up there, it's going to give you coverage pretty much everywhere in the warehouse, okay? Because there's just line of sight between all of the access points. That's the reason why having omnis in warehouses placed up in the ceiling is probably not the best of the ideas. So using directional antennas, you just come back here, select that guy, let's delete it. Let's use a directional antenna. Let's use a Cisco 9120, Cisco in here, and then the model 9120 AXE external antenna. And then we're going to use an Axel Tex. They use the ATS OP 245, 13. Okay, we are in 5 gig. Yeah, let's use this guy. See, it has a 15-degree horizontal and 110 degrees vertical. So if I place that guy, let's say here, let me make sure. Oh, I ended up placing another one there. Let's remove it. Let's make sure that we put the orientation right on this antenna. Because right now, that guy, see, the tip of the access point, that's where the antenna is. This arrow is where it's aiming. So it's aiming in that direction right now. Let's grab this guy and have it shoot down the aisle. This is what's kind of confusing because it feels like the arrow and the antenna is on top of the rack, but it's not. Remember, the tip, the arrow down here, that's where the antenna is. If I move this guy down to have this arrow point down this hallway, it's not because it's here where the antenna is. So I'll move the AP and make sure that antenna is aiming in that direction. That would be the equivalent. Come on. Come on. That would be the equivalent of having this. As a matter of fact, that's one of these antennas. See? External access point with external antennas. And let me bring one of them. Stop sharing here for a second. All right. Access point. Of course, you have to figure out how to mount the access point. Then you have cables. Then you have connectors. Then you have the antenna. Okay. This is one of those antennas we have in the picture in that warehouse. and one of the antennas we're designing. This one is big. It has a 15-degree horizontal. This one is basically like this, really narrow. And it has 110 or 100. Here, I got this spectrum in the back. It has 120 vertical. So it's basically shooting like this, narrow, okay, like that. If we turn the antenna over, then it's going to be doing this. If we put it on the ceiling, shooting straight down, then depending, see the orientation, it has the up arrow on the back. Right here it says up. I don't know if you can see it on the picture, on the camera, but that says up. That's how it is designed to be mounted, like this. The horizontal is 15 degrees. The vertical is 120 degrees. This is designed like to shoot down the aisle at a narrow beam width, okay? The arrow that when we move it, it changes is if we're doing this, we're changing the azimuth. So if we're gonna cover that area, then we aim it in that direction. If we intend to cover that aisle down there, my landing strip, then you turn it like this, and now it's shooting in that direction. It's a directional antenna. And the horizontal, that's the narrow part, the vertical is like this. So if you put it also in the ceiling like that, then this is gonna be covering like that. It's 120 degrees, see? If I put it like that, it's gonna be 120 degrees this way and the 15 degrees horizontal. Okay, questions about this antenna? That's the orientation, okay? That's that arrow when you put it, it's like, where are you aiming? The tilt, what's called the tilt is this, the 10 degrees, 20 degrees, and the antennas like this one, I don't know, I'm gonna try to get it as close as possible. It has some markers in there. You see those, Jocelyn? You see the markers like the number of degrees? Then that's what you would use to see like, oh, if I need to have these guys 10 degrees down or 20 degrees down or 30 or 45 degrees down, that's where you move it and then you tighten these screws and adjust it so that it's at that right angle. It also, say, of course, I'm moving the whole thing, but once you mount this on a post, this also on the very top, see, Jocelyn? It has the number of degrees in case in the design, say like, oh, that antenna has to be 20 degrees tilted down, and it has to be 30 degrees to the right or 30 degrees to the left or 45 degrees to the right or 40. See, just like in which direction you want to aim that antenna. Back together when we're done. And we are getting to the end of this session. But let me share my screen once again. All right, my screen on your screen. So now this arrow is the moving it like that, okay? And now if I want to cover this aisle, come over here, then by placing it here, shooting in that direction, it's covering the whole place. At what height? I don't remember where I left the last height at. If I, oh, like really high. If I say like, no, I want to see what the signal is down at 1 meter from the ground. That's what the guys are going to be. That's about 3 feet. Then, you know, it still covers pretty good. It's 120 degrees. But if I want to tilt it down, see if I select that access point and I say like, I'm going to tilt you down, I don't know, 20 degrees. Then it's aiming at that angle. What if I say, no, how about if I put it 30 degrees down? Okay. Gives really good signal there, neck 30, neck 50. And then now that I have that AP, oh, it's at, of course, it was showing really good because it is at 1 meter from the ground. Duh. How about if we put this guy at 28 feet? So at 28 feet, all the way up there, this is what it's showing down. Look what happens if I put this guy at 0 degrees. It is just if the antenna is flat like that. The tilting then starts going down, and the arrow shows you. Like we have it at 30 degrees down. If I have it at 45 degrees down, see, it may have weaker signals back here, but this is a small space. Okay, these guys are designed to cover like really long hallways. How long is this in here? Let's just measure. This is about 75 feet. We want to see that in meters. Do we even use feet? Here, let's just use meters. It's about 22 meters. That's nothing. These guys will go 100 meters, no problem. So let's just use this access point. Just go over here. And I have it at 8 meters from the ground. Let's just put it down at just 20 degrees tilt. Okay. And then we'll be simulating something like this. This guy, I think these guys were like at 30 degrees. Probably too small to see right there. It's almost a 45. Look at that. Because of the height, you're just trying to aim that. And the mounts, they're one side for the access point, the other side for the antenna. That's how they're mounted. That's real life. This is the simulation. Now, I can either use this same access point. Okay, let me see, Control C, Control V. Then just put this guy on the next aisle. And then Control V again. Oh, put it up here. And then put it down the next aisle. And this is what they do in a lot of places. Let me Control C, Control V. I just get one antenna the way I want it, one AP with the antenna and everything, and I just aim it. And then copy paste it, and then I have all of them aiming down there. In other places, what we recommend is doing what's called striping. Because see, these guys send signals down there, but then there are some areas here that are not well covered. If I were to like stripe it like this guy, let's say, oh, we're missing a guy over here. So if I place that guy over there, Control C, Control V, and let's say the next aisle, I'm going to cover from here. See? But instead of aiming there, I'll be aiming the opposite direction. So I'm going to aim it in this direction. And let's say if this guy is going to be here, kind of like how it is in the in that example, that there's open space in here. See, that guy's not against the wall. It's like here in this area, shooting specifically down that area. And then this guy is going to go the opposite direction. And then let's say this guy, Control C, Control V, I'm going to be aiming in the opposite direction. So that guy has one coming. This guy has one guy going like right there. And then this guy, maybe I'm going to place over here. Oh, yeah, let's do this. Watch. Let's say we're going to place this guy over here, but not aiming in this direction. Let's say we're going to aim that guy in that direction. Okay. Or we can even place this guy in this area, aiming in that direction. So it's just a matter like, what do you need to cover? What area do you need to cover, and how are you going to aim this guy? Or in this area, I could just place an omnidirectional antenna. But by doing striping, I'm covering all these areas. See, covering that in that direction, and the side lobes will take care of this area. This guy shoots down this aisle, but then the side lobes will cover this area too. And same thing with this guy. See, that guy alone covers that, which is the intended, and the side lobes cover this. Not having those dead ends as we did before. We could use a different type of access points in the office space. So like if I am, just get out of here, and of course we'll have to adjust the heights of these walls and stuff because they're too high, but you know already how to do that. Let's just choose a Cisco 9120, but this time one with internal antennas. That's what the I is, XI, internal. The E is for external. This one is an Omni. See, if I hover over this guy, that's it. That's an Omni. And if I place it then, let's say in the office space, one over here, maybe one over there. And if I need one in this area, place one over there. And that's it. These guys, let me see, make sure that they are not at 20 something, at 8 meters high. This is just 2.5. We'll have to come in and change the height of these walls and adjust it just to be that area. As a matter of fact, I think I have this one already finished here somewhere. Let's say Hamina training, Hilton, Hockey, Hospital, multi-floor. Oh, no warehouse. Yeah, let's try warehouse. DR warehouse. Yeah, let's try this one. Yeah, that's this guy. Okay. If I go to 3D, yeah, it looks like I made the attempt to make those walls lower, but not all of them. I still have to come in and adjust some of the other walls and some of the doors and some of the stuff. But it's just a matter of playing. You already know how to do all of these things. If you want to replicate this, you'll have a license. You have the floor plans. Now you have some ideas on how to start designing. In some of these places, like we had to design, let me just go back to the Nave one we had created, this guy. We had to use a different type of antenna, a semi-directional one that was like 60 by 60, and then just place him on the ceiling, covering like areas like that. Not like really narrow shooting down one aisle, but more like a 60 degree by 60 degree, and then you just place him on the ceiling, shooting down, covering the area that you want. That's to, like, for instance, this guy is covering that area. If you don't want, let me bring this guy over here, like there, like right there. And then I can, that guy relocate to the ceiling. So I have that guy on the ceiling shooting straight down, okay? And turn it in this direction. See, I'm covering the same area, okay? That aisle. But then, since the access point, instead of being in one corner shooting straight there with a narrow beam and it's 120 degrees, I'm putting it down in the ceiling with the 120 like this and the 15 degree horizontal like that. So by changing it like this, if you are down here, if you are connected to that guy from here, you are 10 meters from that guy. If you're on this side, you are 10 meters from that guy. But if you put it, if you are now looking at this antenna and you associate with that guy and you're all the way out here, okay, then you're going to be connected 22 meters away from that guy. So that's another approach, is placing this type of antennas in the middle area, not mounted sideways, but mounted all the way straight down with the right orientation, is going to provide that type of coverage. All right. I think with this, my friends, we come to the end of session 370 of Tesos and Wi-Fi. Hey, for once, we covered what we said we were going to cover. We were going to cover capacity. We're going to cover the client view, the roaming stuff. We did that in the office area. And then we cover warehouses. Now with warehouses, we are playing with bigger, taller obstacles. It's no different than the office. It's just that instead of having a 90 centimeter tall desk, you have an 8-meter tall rack. And then we also learn how to use and edit and bring racks. Look at that stuff, man. This is really cool. Bringing racks and bringing other stuff from these tools that Jerry showed us this week. One is the attenuation object database that has lots of racks and desks and chairs and things already built for us, thanks to this guy, Robin. I think he's from Belgium. I think I checked the About Me stuff. Let's see, where is he from? Yeah, Belgium. Robin de Cloet. Who speaks French here? Jocelyn, how do you say that properly? Yeah, you're laughing like, yeah, you idiot, you said it wrong. How do you pronounce that correctly?
I think it's the same thing. The Cloet.
Okay. The Cloet. Okay. So
It's a Solette.
made time on his schedule to come and build all of these beautiful databases for us. Oh, I lost it. Where did it go? Tools, come on. Hey, let's just go home then. Oh, where is the stuff? Tools, about me, Hamina objects. Here we go. Then all these are really cool. And I also learned today that you can just copy this, bring it to Shettl's tool, and then in here, you can modify just by pasting the code in here. So instead of copying here, instead of pasting it directly to Hamina, you just bring it here first, and then go to the object editor. See this guy, object editor? And then once you go in, you paste that code in here, and then let's just do it. Let's just grab, I don't know, this guy. Let's copy this code, because in here you cannot modify it, right? It is what it is. Then you bring it over, go to object editor, paste that code in here, load the object, and there it is. See? Now here, this is helpful because now you can rotate it. If in Hamina, because here's what happened. In Hamina, I needed this orientation, and the one I copy pasted was the other orientation. So who was it? Wallet or just, I don't know, someone showed me that I could come here and then from here change the rotation. Okay. So if I have it at, let's say 90 degrees, then now it's going to be in the other orientation. And I don't know, I'm sure it's somewhere in here is changing that code for everybody to do it. So when I copy it to Hamina, then it's going to be pasted. Control V. Where did it paste? Where did it go? Here. So it pasted it with that orientation. If I come here and rotate it again, leave it like this, copy to JSON, come here and Control V. Now notice that it brought it over, but now it's rotated. Because I don't think here in Hamina there is a rotation thing for this guy, like that I can right click and move around. Nope. If there is one, I don't know how to do it. We'll ask Jerry. And I think that's it. Today, that's what we covered. This is the end of session 370 of Tesos and Wi-Fi. Hey, Thor! Good afternoon, amigo. How's it going? Then today, this is part of the class, the free class that we have, a wireless LAN professional for design. This is really cool that you can use these external guys' tools. They put all the time and effort to give this to the community for free. I mean, it's not completely free. You can buy coffee for Sheto. See, you gotta buy, him some coffee. Just come over here and give him some. I'll send him some later today. But then that's what we covered today, doing warehouses. And we also took you on some real warehouses and some installations and some issues that we had over there. And we explained why having omnidirectional access points in warehouses, can give you some problems because they are covering the entire place once they are up high. Every single option in here you have already used. We learned about modifying heights of obstacles, how to create new walls and doors and windows and stuff for these spaces, like where the conveyor belts are, where they put the merchandise. That's nothing but another attenuation object. Let's see if I have another warehouse where I have this guy's already drawn. No, it's not here. Training, let's see. Hamina training. Hilton Hockey Hospital, multi-floor. What is this? No, that's not it. But let's just actually do it real quick, and it's not that hard. Watch. Not you, the other warehouse. Where's the other warehouse? Maybe this guy, or that's where I am. Let's go to that. This one. Yeah, this one hasn't. Watch. This is one of those conveyor belts. And all it is just another attenuation area that is only this high. Let me remove the visualization. And then that's a conveyor belt that is a space that is attenuation area that is floating. See? But it doesn't go to the ground, it has some legs and some belts in there. but then this is that space where they put the merchandise and then it rolls over. That's just another attenuation area. So everything basically that you can see here in this design, you know how to do. You have the tool, you have the license. Thank you, Hamina, guys, for giving us licenses. You have the knowledge on how to create walls, doors, attenuation areas. Now you have these additional tools that already have racks built for you. And Shettl's tool that will give you options to how to modify those things. And then just, it's as simple as copy, paste, then bring them over here. And yes, it takes time because once you are, let's see this guy. Let's see if this is the right one. Once you are drawing and modifying all of these things, it just takes time sitting there, trying to figure out where to place access points, where to place the attenuation areas. Just do the right here. And come on, yeah, this is the guy. All of this stuff was done using what we have learned this week. It's nothing different. It's just at scale. It takes time. Yeah. To place the columns, to add the APs, to change the orientation of the APs, to add attenuation objects, to add all of these obstacles, to add, you can add chairs, you can add walls and things, all of this stuff. As I go through this area, is a simulation of this real space. Let me just go back out of here. Man, I'm gonna have to reboot my computer again. I wonder why it's going so slow. Come on, come on, come on. I'm trying. Yeah, just go to library. And let's just go to library again. And that was just a simulation of all of these spaces. The columns, the trusses, the lights, the APs hanging from the ceiling, the APs on the walls. Notice that these guys did have the tilt. Now you know how to simulate all this stuff, okay? The APs at that height, at that tilt, at that orientation, that's what we do with this stuff, see? Just defining the columns, the racks on the floor, walls, doors, obstacles, screens. See all of this stuff. We have all the screens out there, see? All of those screens are simulated the same way. All right, my friends, I think with this we get to the end. Thank you very much for coming. Now you know, free love for everybody and free Wi-Fi training to everyone. So enjoy the rest of your weekend. I'll see you next session.
Have a go, Renee.
Much.
Tom, you as well.
Have a nice weekend.
Okay.
Bye-bye. Let me stop the recording.